Welcome to Lesson 3E, Exposure Level Regulations. If you're following along in the book, we're into Chapter 3 now. We're going to discuss all these things: contaminant exposure level, fire and explosion, noise, heat stress, odors. There's other things besides air pollution that we'll talk about for indoor air quality. Let's look at contaminant exposure levels first. There's some acronyms that you need to know. The first one is ACGIH. This is not a government agency. It's kind of like ASME. It's just an organization. They publish TLVs, which are threshold limit values. These threshold limit values are what ACGIH recommends as the maximum exposure level for vapors in the air in ppm or in milligram per meter cubed. So they're either a mole fraction or a mass concentration. These are recommendations only. The ACGIH has no regulatory ability, so they can't regulate, they can't enforce. OSHA is a government agency. They publish PELs, which are permissible exposure levels. These are regulated, so OSHA can regulate and enforce and inspect, and they can levy fines. So OSHA is the one that you have to be really concerned about. If you're a company, they can come in, test your air, and if you don't meet their permissible exposure levels for a certain chemical, they can actually give you a fine and force you to comply or shut down. So they're a very powerful agency. All of these are in ppm or milligram per meter cubed. NIOSH is kind of a strange one. It is a government agency, and they publish something that's even different than the other two. They publish what's called an REL, recommended exposure levels, again in ppm or milligram per meter cubed. You know how to convert between Y, J, and CJ through previous equations. The difference here is that it does not enforce, it just recommends. So NIOSH is a government agency, but it has no authority to regulate anything or levy fines. Big difference is that NIOSH REL assumes a 10-hour workday, and the OSHA PEL assumes an 8-hour workday. In this course, I'm going to put a big box around the OSHA and some stars because we'll always use the PEL for everything we do pretty much. And I just wanted to note that sometimes the PEL, the REL, and the TLV may differ. Take the same chemical and you look up these. By the way, these are not published readily because that's kind of a private organization and you must purchase. They sell these TLVs. So that's why TLVs, except for a couple of them, do not appear in my book, and you're not going to find them online unless they're pirated copies. They're just recommendations by this agency. But OSHA is the one that these are readily available, published, they're online, and so are the RELs online because they're government agencies. But the PELs is the one that you have to meet or you could be fined. These may differ. Again, the PEL and the REL are found on this NIOSH Pocket Guide. If you go to the links and look at the NIOSH Pocket Guide, and then you pick, let's just pick, for example, benzene, click the B, and you scroll down till you find benzene here. I wanted you to notice they have the NIOSH REL and the OSHA PEL. And from this NIOSH Pocket Guide, I would encourage you to use that. By the way, we have PELs listed in one of the appendices in the textbook, but those are about 20 years old at this point, and they do change when they discover that chemicals are more harmful than they thought they were, or vice versa. So sometimes these change with time. So always look online for the latest values of these PELs and RELs. Here's the NIOSH REL. Notice the TWA, the time-weighted average, 0.1 ppm, and OSHA PEL is 1 ppm. So they differ by a factor of 10. Now that's kind of an extreme case. Typically these are much closer to each other and often they are identical, and you can look at the measurement methods if you want to look these things up. They do slightly different methods. As I mentioned, they take either a 10-hour or an 8-hour exposure time, so that makes a difference. Plus they measure these differently. So just keep in mind that these can be different, and we will always use the OSHA PEL. They also have some other interesting things: molecular weight, boiling point, freezing point, vapor pressure, etc. Let's talk primarily about PELs, since that's what's regulated. These are concerned with workplaces, not houses, not where you live, but where you work. So in the workplace, PEL is enforced by OSHA. And if not in compliance, you can be fined. As I mentioned, OSHA can give you fines. If you don't change and try to improve, they can actually shut you down. And they're very concerned about keeping workers safe. That's the main goal of these PELs, is to keep workers safe. TWA is a time-weighted average. And typically, again, this is for 8 hours. It's an 8-hour day, 40-hour week, they assume. So we have chemicals that are known to be harmful, but as I've talked about before, they're harmful only in certain concentrations. If you have a very small concentration for a long time, they might be harmful. If you have a large concentration for a short time. So they're basing these on 8-hour day, 45 days a week, 40-hour weeks. And then they can monitor these with a dosimeter, which just measures dose. And these come in various forms. The nicest ones are little pocket dosimeters that you wear on your pocket, and they just continuously test the air and record it so that you can see if you're in compliance. As I mentioned, these OSHA PELs are available for free. The TLVs are copyrighted, not available freely. And in general, TLV is often less than the PEL. Now, why would that be? Well, this agency that's doing the TLVs, the ACGIH, they're doing their own testing and they do it quickly. And so what you'll often find is the TLV might be lowered because they say this chemical is nastier than we thought. So we're going to lower the TLV. We're going to make it a little bit less TLVs, so we're saying the threshold should be lower. In other words, it's a more hazardous chemical than we thought. Usually several years later, the PEL might change to match the TLV, but sometimes it doesn't. I forgot to mention when I was up here, recommended. That's kind of a funny name, recommended, like you're recommending so much vitamin C per day. No, that's a poor choice of wording, but it means recommended limit is what it really means. But they couldn't use permissible or threshold because other agencies already use that, so they used recommended. So I just find that kind of amusing.
Yeah, I don't find that amusing.
Well, I do, Iggy.
Yeah.
You might even ask then, why TLV if we're going to use the PEL for the regulation? This is typically more conservative and quicker testing and changes. If you know anything about government, there's a lot of red tape to change anything in the government. So even if some chemical is found to be more harmful, the PEL will take several years to change, whereas the TLV is just some vote in a committee and they change it and republish it every year. Some companies use the smaller of the three, and that is in order to be conservative. So to avoid lawsuits, well, there could still be lawsuits, but if you say, I'm using the TLV because it's the smallest and therefore my workers are most protected, that was the information, the best information we have, you're most likely not to get sued and lose the lawsuit. Now, there's various kinds of PEL, so I want to talk about that next. And I mentioned TWA, and you saw an ST, etc. So let's look at these in detail. TWA is time-weighted average. We would call this PEL-TWA. By the way, if you just see PEL without any TWA, it means PEL-TWA. We will assume that unless stated otherwise. So this is the most common one. The PEL-TWA is defined as 1/8 integral 0 to 8 of Cj as a function of time dt. This would be in milligram per meter cubed, or 1/8 integral 0 to 8 Yj of t dt. This would be in ppm. You can do it either as a mole fraction or as a mass concentration. So that's the definition. And this is the time-weighted average. Note that in both of these cases, T is in hours, not minutes, not seconds, hours. That's why there's 8. They're averaging over 8 hours of workday. The rule is then the exposed, in other words, what the workers are exposed to, the exposed TWA averaged over 8 hours must not exceed the PEL-TWA that OSHA publishes. If this average, if you actually do the average here and it exceeds the PEL that's published, then you're in violation. I just want to comment here that we will often drop the J subscript if we're talking about one chemical and not a mixture of gases. So sometimes you'll see these equations when I write things, especially later on with room analysis, ventilation, we'll drop this J subscript in here. I'm just putting it there now because that's what we're used to. That's the TWA. There's also an S STEL, and that's defined as the short-term exposure limit. This is generally greater than the TWA. It's similar to the TWA. It's still a time-weighted average, but it's over 15 minutes instead of 8 hours. So this is an 8-hour average, TWA. The STL is a 15-minute average instead of an 8-hour average. So it has the same equation, PEL-STEL. Some people just call it PEL-ST, not STEL, and that's equal to 1 over 15, integral to 0 to 15 of CJ dt, or 1 over 15 integral 0 to 15 yjt, and t in minutes. And of course, this would be ppm, and this would be milligram per meter cubed. So make sure you look at your units. For the STEL, the exposed STEL must not exceed OSHA's PEL-STEL. So exposed just means what you're measuring, actually measuring with the dosimeter. PEL is what's published by OSHA. Okay, there's one more that we'll talk about, and that's C, is simply ceiling. And this is a level, either ppm or milligram per meter cubed, never to be exceeded, even instantaneously. And so you're not allowed to go above that level ever. So obviously C is greater than STEL is greater than the PEL-TWA. So that should be obvious because of the way we're defining these. There are rules. I've given you a couple rules already. I just typed all these up for convenience. There's 5 of them. The 8-hour time-weighted average must be below the PEL-TWA. Ceiling must never be exceeded, even instantaneously. The instantaneous value must not exceed the STEL. You can exceed the STEL instantaneously, but not more than 4 times in an 8-hour period, not more than 4 spikes above the PEL. And if there are spikes above the STEL, they must be at least 1 hour apart. But the 15-minute time-weighted average must not exceed the PEL-STEL value. So those are the rules. And now I want to do a couple examples. First example, we have workers in a chemical plant that are exposed to benzene vapors. OSHA tests the air with the dosimeter, and this is what they find in this particular plant. They're turning on some machines or something, and they have this kind of a behavior. So what I want you to do is calculate the exposed 8-hour TWA. So that would be the average mole fraction concentration to which the workers are exposed for an 8-hour period. That's what this 8-hour TWA is. This is exposed in units of ppm, and then compare that with OSHA PEL-TWA and see if it's in compliance. So the solution, first of all, you're going to have to look up for various chemicals. The OSHA, this is the one we'll be dealing with because that's the one that regulates PEL-TWA. For benzene, that happens to be the example I just showed you. And if you look back in this video or on the notes, it's 1 part per million. So we have to see if our value is greater than or less than 1 part per million. Just looking by eye, it looks like it's going to be pretty close. So if I draw a green line through here and say this is the PEL-TWA, and it looks like it's above it sometime and below it sometime, and it's hard to tell by eye, so we got to do an integration to calculate. So let's integrate. TWA exposed is equal to, again, these are in hours, and I have this in hours, and YJ is in ppm, so the scales are already correct. You'd have to do unit conversions otherwise. 1 over 8, 0 to 8, yj of t dt. And this one you can do in your head. The easiest way is to just look at these blocks. So this first one is a width here of 1 and a height of 0.5. So it's 1 hour times 0.5 ppm. So this is 0.5 ppm hours for that block. And then for this block, the next segment, you have to do this piecemeal. 2 hours times 1. So this would be 2 ppm hour. And then you keep doing that for various steps. And I'm not going to keep doing all this in detail. This would be 1.5, and then this one would be 4, and then finally this one over the 8-hour period. Then they're shutting everything down. It ramps down like this. Use your triangle, 1/2 base times height area, and you get 1.5. And so to find the exposed TWA, we just add up all these values. This would be 1 over 8. I'm going to put the units in here, 8 hours. And the integral, we already did the integral with these values, so we're just going to add all these guys up. So this would be 0.5 plus 2.0 plus 1.5 plus 4.0 plus 1.5. These are in units of ppm times hour. And so you end up with 1.19 ppm because the hours cancel in these units. And so I would say that here the workers are exposed to, I'll round this to 1.2 ppm, which is greater than 1.0 ppm, which is the OSHA value. So this is not in compliance. That's my answer. So you can be fined for this case. I'm going to do another example. This one's a little more complicated. I used Excel. How to determine if there's a violation of the exposure limits or standards. I'm showing here instantaneous and running 15-minute average mole fraction in ppm of a contaminant. So this is the YJ that we're actually measuring, and this is time of day. You can see those are in 1 hour units. So the workers come in at 9 o'clock, they leave at 5 o'clock, and we're not counting a lunch hour. Here they're just eating lunch at their desk, and they're exposed to this air constantly. This is just for some generic chemical, so I just picked some values here. So you can see I have the TWA, PEL, the STEL, and the C. And I rewrote all these rules here so we can compare. Is this in compliance? Well, first of all, what are we plotting? The black is the instantaneous, and I'll put that in quotes. It's typically every 5 minutes you have a reading, or you have an average reading over 5 minutes, depending on the dosimeter. But in this particular example, I had data every 5 minutes. The red line is a 15-minute running average. So you can't average the first 2, but after you have 3, the first 15 minutes, you can get an average. There's a point there, a point there, and a point there. You average these and you get that point. And then you average the second one, third one, and fourth one to get the second point, which would be here. This is easy to set up in Excel. Once you do that, you can keep filling down. So you're sampling the last 3 readings, and that's a running 15-minute average if you're taking readings every 5 minutes. If you take them every minute, you'd have to sum 15 of them up and divide by 15 to get the running 15-minute average. So anyway, it kind of lags the instantaneous, and it doesn't go to as high a peak. So that's typically what happens. It smooths out all these bouncing around, and it makes the peaks smaller. So let's look at these rules. The 8-hour time-weighted average must be below the PEL. So if you take an average over the whole instantaneous value, in Excel you just add everything up and divide by the total number of runs. So this is the exposed TWA that I measured. Just take the average of all those points. And this is the PEL TWA, and you can see that it's below, so we meet this criteria. The ceiling permissible exposure level must never be exceeded, even instantaneously. It came pretty close a couple of times, but we never exceeded it, even instantaneously, so that's okay. The instantaneous value must not exceed the short-term exposure level, except more than 4 times. Well, here's the STEL, and the instantaneous one has exceeded it 1, 2, 3 times. So 3 is less than 4, so that's good. So not more than 4 spikes, so this one's done. And number 4, if there are spikes, which there are, there's 3 of them, they must be at least an hour apart. Well, you can see, I don't know exactly here, but we're going from 10:30 to 1 or something. So this is definitely greater than 1 hour. And this one also is greater than 1 hour. So if you had 2 spikes close together, less than an hour, like 20 minutes apart, that would be a violation. But here, those are all okay. And then the 15-minute time-weighted average, the running 15-minute average, this red curve, must not exceed the PEL-STEL value anytime. So this first peak didn't come real close. This second peak came really close. Third peak, not so bad. So we never exceeded it. We came real close, but that one's okay. So the final conclusion, the air in this plant meets OSHA regs. And so therefore there's no fine, and we're happy about that. What if you have a mixture of gases? We've been talking about just PELs for one gas. We even drop the J subscript when we do that sometimes. So for a mixture, here's what OSHA defines then. EN, which is called an exposure parameter. It is a sum over all the J's. So say there's 3 or 4 different contaminants that you're worried about. You take the mole fraction, and this is the exposed, divided by the PEL. You can do this for any of those 3, ceiling. You can do it for TWA or STEL. PEL. So we're going to just do it kind of vaguely here. This can apply to any of those things. So this is the definition. And the rule then is if EN is greater than 1, it's a violation. If EN is less than 1, it's not a violation. So it's a nice simple equation and a nice simple way to look at it. It has to be greater than 1 to be a violation. And I'll do a very quick example. Suppose we have a mixture in some kind of a chemical plant of 3 chemicals, benzene, and the YJ, and let's just assume this is all time-weighted averages over 8 hours. So suppose that's 0.4 ppm, acetic acid, and then PERC measured for the workers. So these are all exposed. This is what the workers are exposed to. So we asked, is this an OSHA violation? Well, you use this definition of EN. You have to look up the PEL for benzene, acetic acid, and PERC. We already know what benzene is. That's 1 part per million. So here, EN is just the sum of the actual. These are the YJs, actual exposed divided by PELs. So we have 0.4 ppm over 1 ppm. And then 2, I'm going to stop writing ppm all the time just to save time. You look up for acetic acid, it's 10, and now this acetic acid is not as harmful as benzene, so it has a larger PEL. You're allowed to be exposed to more of it. Finally, 30 over, look that one up for PERC, it's 100, so that one is a much less harmful chemical than any of the other ones. When you plug in your calculator, you get 0.9, which is less than 1. This is acceptable.
Thank you for watching this video. Please subscribe to my YouTube channel for more videos.